I'm going to go ahead and review the heparin protocol, and I will I'll also give you a variation of this since you have seen this before. I'm going to give you just a different patient weight, because that's how this question would be set up. Is there would be a different patient weight, and then you'd be asked, that you'd be shown the protocol, which is the steps 1 through 15, and then you're asked to answer 2 of the questions here. So most likely it'll be to answer question A and B, but you also should be prepared to answer question or parts C1, C2, but you'd only get 2, 1 bolus, 1 infusion rate question on your test. So, and you could see on my screen, this was one I did earlier today. So it's already up on YouTube. You can actually see me working through for a 184-pound patient. So I'm just going to create and start with a different value and then see what we get.
I was on the earlier Zoom, but it was just kind of fast. So I just wanted to see this again, like talked out a little bit slower.
Okay, I can slow down.
Cool.
Do you want to do just the 110-pound patient, or do you want to go ahead and do like a different weight?
Can you do a different one?
Sure. Say 176 pounds. So the first part we need to do is we need to convert the patient's weight in pounds to kilograms. So 276 divided by 2.2 give me 125.45 repeating. 125.4545. And what I'm going to do is I'm going to go ahead and round that to 125.5. My guess is, in reality, if we're talking about an adult patient, you probably would just do 125 kg, but let's just be specific. You're being told to round to the nearest tenth, so this is what we're going to work with. So going back to the protocol. Protocol states that we need to do a couple things. We need to bolus the patient with 80 units per kilogram. And the first part of the question says to calculate the number of milliliters to administer for the bolus. So everything that we start off with is just what's the information for the bolus. So 80 units per kilogram. Then we need to know the bolus dosage strength so we can convert units to milliliters. And so the bolus dosage strength is 1,000 units per milliliter. So let's go back to the screen. One of the benefits of having me do like a patient's weight that I haven't done before is because I don't know the math already, this will cause me to slow down. So, okay. So we're going to take the patient's weight, which we calculated at 125.5 kilograms. And we're going to multiply by what we were told to multiply it by, which is the 80 units per kilogram. So I'm going to take that 125.5 times 80, and I'm going to get 10,040 Now, if this question just said how many units to administer, we'd be good to go, but it doesn't say that. It says how many milliliters to administer. So we need to do the conversion. So in order to figure out what our conversion factor is, we go back to the protocol. And step 2 of the protocol is what tells me and tells you what we have available. We have a bolus dosage strength of 1,000 units per milliliter. We also have heparin 25,000 units and 250 milliliters, half normal saline, but that is for your infusion rate. That's for your flow rate. So we would only use the heparin 25,000 units and 250 ml half normal saline when we're looking for milliliters per hour. When we're calculating bolus, we use the bolus dose information. So I can do this 2 ways. You can do this the dimensional analysis way, or you can do this ordered over half. If you're doing ordered over half, you would just divide by what you have available, the 1,000 units multiplied by the volume, which is 1 milliliter. And then you're going to get 10.04 milliliters. Now, as a reminder, when you have a number greater than 1, you're going to round to the nearest 10th. 4 is not going to bump that to a 1. So you would round your answer to just 10 milliliters. So the bolus dose strength for a 276-pound individual, 125.5 kilogram individual would be 10 milliliters. That good?
Yeah.
Part B. Part B says to calculate the infusion rate in milliliters per hour for the heparin IV drip. We're going to start the patient after we've given them the bolus dose. They're already attached to the IV. Now we're going to start infusing at 18 units per kilogram per hour. So my first step is to figure out how many units per hour that is. So same patient, same weight. But now we're going to multiply, instead of 80 units, we're going to do 18 units. And this is kilogram hour. I'm going to take my calculator, 125.5 times 18. It's going to give me 2,259. So 2,259 units per hour. Then I need to know how to make, or how to do a conversion. So I'm going to go back to my protocol. And I'm going to again look and see that I have available an IV of 25,000 units in 250 milliliters, half normal saline. So that is what we utilize for our flow rates, because that's the IV. That's what they're attached to. That's the bag with the solution, which has heparin in it. I'm only going to use the bolus dose for bolus doses. And if I only want to calculate just milliliters, but if I want to calculate flow rate, that's where we're going to use our IV solution, which is the 25,000 units in 250 ml. So your order for this type of problem would be like the 2,259 units per hour. You're going to divide by the 25,000 units and multiply by the 250 ml. So I know, like, I sometimes show this as dimensional analysis. Sometimes I show it like this just to create some variety. So I'm going to take that 2,259. I multiply by 250. And then I divide by 25,000. And the number I get is 22.59. And this is milliliters per hour. Again, we're going to round that number to the nearest tenth. So 22.6 milliliters per hour. Are you okay with parts A and parts B? Is there something that is confusing or you need to see written a different way, or do I need to explain again? Just let me know.
Good.
Okay, good. So in all likelihood, your test, this is what you're going to see. You're going to see solve for the bolus, solve for the flow rate. And that's what you're going to have, two parts for one question. If you get both parts right, you get the question right. If you miss one or both parts, then you miss one question. And this is likely the question you'll see is just to start the heparin protocol. On the off chance that you get asked to do another portion of the protocol, that's where the second set of questions comes in. So it says for an APTT of 43 seconds, what is the new bolus and what is the new infusion rate? You'll see that boxed in steps 11 through 15 are after we check the APTT, what do we do? So if it's had said 30 seconds, we would follow step 11. If it had said 50 seconds, we would follow step 13. If it was 80 seconds, then we would follow step 14, but it says 43 seconds. So 43 seconds is what I have highlighted here. You're going to rebolus the patient with 40 units per kilogram, and then you're going to increase the infusion rate by 2 units per kilogram per hour. Keep in mind that the original was 18 units per kilogram per hour. So when we increase by 2 units per kilogram per hour, we're going to do a new calculation based on 18 plus 2, which is 20 units per kilogram per hour. If the APTT was 30 seconds, then we would be increasing the rate by 4. So that would become 22 units per kilogram per hour. So you just follow with what it says. So let's start off with the bolus, and then we'll come back to the infusion rate. The same patient, same weight. Instead of 80 units, we're going to do 40 units. $125.5 times 40 gives me 5,020. This time I'm going to write it out dimensional analysis style. So if you like this, you can do this the same way. We're going to use the same bolus dosage strength, the 1,000 units per milliliter. I'm just going to write it out a little bit differently. I'm going to plug that into my calculator, and I'm going to get 5.02 milliliters. Again, I'm going to round to the nearest tenth, which would just be 5 milliliters, because I wouldn't round up. 2 doesn't round 0 to 1. So what I've done here, what I did here, I used the same bolus dose strength information. The difference is in part A, I used ordered over half. In part C1, I used dimensional analysis. We're doing the same thing. So if you set this one up exactly like this one, if you prefer that method, you're going to come up with the same answer I did. If you set this one up like this, again, you're going to come up with the same answer that I did. Then finally, C part 2, same patient weight. Let's go back to the sheet so we know what to do. So it tells me to increase the rate by 2 units per kilogram per hour. My original rate was 18 units per kilogram per hour. So I'm going, that's the number I'm going to increase. So I'm going to go from 18, then I'm going to add 2 to 20. So I'm going to multiply by 20 units per kilogram per hour this time. Before we did 18 units per kilogram per hour. Now we're going to do 20. $125.5 times 20. And I'm going to get 2,510 units. That's per hour. Now the question says to calculate milliliters per hour. And so what I have to do is I have to convert units per hour to milliliters per hour. And that's why I use what the IV solution that we have, the 25,000 units of heparin in 250 milliliters, half normal saline. Those are the numbers I'm going to use. So if you're using dimensional analysis, and one of the benefits of dimensional analysis, if you ever get stuck and you don't know where to put your numbers, if you set up your units, you'll at least know you're in the right ballpark. And then you can say, well, okay, so I'm going to put the number that goes with units here, 25,000. I'm going to put the number that goes with milliliters here, that's 250. And that's how we'll get our, that's how we set that up, dimensional analysis. If you prefer to do it this way, you can do it that way as well. You'll come up with the same answer. And that answer is going to be 25.1 milliliters per hour. Any questions on any of those or any of those steps? Anything that you need clarification on, or any other questions?
No, I'm just looking at C1 and how you set it up. And I'm just trying to like think about it. Like, can you explain just like the whole writing out of like C1?
Sure. So do you know where we're getting the 40 units from?
Yeah.
Okay. So all I'm doing is taking the patient's weight, multiplying by the 40 units, and then I get that number units wise. Now, do you prefer to write your math like this?
Yeah.
Okay.
I don't know. I do like order over half, but I do it like number, whatever the thing is, over 1, and then I like crisscross it so I can
Okay.
actually see the units crossing in a diagonal.
Okay, that's fine. That's, yeah, as long as you're getting the right answers, you're doing that right. So the only thing I did differently here is if we can just put the 1,000 underneath here, and that should be consistent with what you're doing. So if you just put the 1,000 underneath the units here times the 1 milliliter, that should help clarify and show it to you the same way. So like, does that look better to you, or like make you feel a little bit more at ease seeing like?
No, I do it 5,020 over 1 times 1 ml over 1,000 units, but I get what you're doing.
Oh, okay. Okay.
I was just somebody was talking to me while you were talking on that problem, so I didn't really
Okay.
get to pay attention that much, but I just wanted to like hear your explanation, that's all.
Okay. Yeah, I apologize. I'm always trying to on
No, you're
Zoom.
good.
I'm always
Somebody in the background was talking, that's all.
okay. I was
At my
just saying
house.
during Zoom, I'm always trying to suss out like what's the root of your question. Like some of it is just the way sometimes that I write it out, it's not clear. Sometimes, or you prefer to do your math a particular way, and if I show you a different way, it kind of makes you upset. But you're doing it the same way I do it, which is the dimensional analysis way. So, so yeah, you're good as far as that's concerned. As long as you know where I'm getting these values for, you should be okay. Just remember, this was coming from step 2 of the protocol. That was coming from step, I think, 12 of the protocol. Does that make more sense now?
Yeah, just
Oh, I
my
did that.
other question is like, it says calculate like the C1, it says calculate number of ml to prepare. Like, how do you know how to get to the ml though? Like, because like, so the rebolus was 40. That's talking like there's no ml. So you get what I'm saying?
Yes. So the reason I know is because it's the same. So I'm back on the sheet here. The reason I know is because it tells you to rebolus with 40 units per kilogram. So that's the only thing it tells you. And this question should say calculate the number of the rebolus, calculate the number of milliliters of the rebolus to prepare. And that would probably help with clarifying
Yeah.
what that is. So the reason I know is obviously because I wrote the question, but at the same time, I do believe I just copied this question out of a textbook or I found it online. So there is some ambiguity, but don't be surprised. Like when you take ATI, when you take the NCLEX, there might be some ambiguity in your questions. And so you just kind of have to look at the information and realize, okay, when they're talking about milliliters, they're talking about bolus. When they're talking about flow rate, then they're talking about the milliliters per hour. And so that's my advice on how to kind of figure out why or what you would be looking for and why you would do that.
Yeah. Okay.
Yeah.